Hey there YouTube. I'm back with my new mill, new to me. I've made a couple of videos about this mill before. I just started to do the electronics cabinet. I'm really excited. The parts are coming in and I'm really looking forward to getting started with this now. And I'll give you a few shots of what's going on. I have a plan for the gearbox that I discussed a little bit before. I'll get back to that later. Now I'm sitting here with the wires and the contactors and the relays. My new circuit boards have been shipped from Germany, which is going to be really cool. My first manufactured circuit boards, all white and shiny with the silk screen and double layer copper. I think that's going to be cool. So let's have a look at where I'm starting at. Okay, so this is the electronics cabinet now. It's all empty. Got a few wires hanging there, but that's about it. It's time to fill her up. And I've taken out the back plate sitting here. I've cleaned it. You see the transformer, which is about, pretty much the only thing sitting here. A few relays, or for a few circuit breakers. I have cleaned up this connector block. It was oily and greasy, and I replaced a few of them, and it's time to start. I'll give you an update as we go. Okay, so here's the process for each cable. I've started in a small way here, and I'll just demonstrate what we do with every cable. I have the diagram here, and right now I'm working on this wire right here, which goes from the 0 point on the 5.5 volt on the transformer down to this point 20 on the connection strip down here. So, and as you can see, each wire has a number, and since it's going to be quite full in here, I figured it's a good idea to mark each wire. And I do that with heat shrink that I print from this Dymo printer. I have 72. Let's see if you can see that. I don't know if you can see it, but it says 72 twice. So I print them and cut it, and I have a piece right here. Looks like ordinary marking tape. They're a little bit hard to split, so what I do is I use this O-ring peeler or a gasket peeler just to split them like that. Shoot. Like this. Put it on the wire like that. Heat it with a heat gun on the back side. Like that. Strip the wire. Like that. Twist it. And I have these little ferrules that I put on the top. It's like a metal cap. And I have this special plier to crimp it. like that. So I don't know if you could see it. It's a nice connection for a screw terminal. And I hook it up with my screwdriver and like that. I'm going to have a channel here for the wiring. Put it down into the rest without making it too tight. And down here, it's supposed to go to the point number 20, which is located right here. The contactors are for
switching high power, high voltage. On the first one there, you can see the contactor. It has is for three-phase. They rate up to 600 volts, and they're controlled by, in my case, 48 volt DC. That 48 volt is switched by the circuit boards that we'll get to later with relays. So the relays are actually generating the input signal for the contactor, which in turn switch on or off the three-phase. On top of the contactor, there's some auxiliary switches. There is also one or two on the contactor itself. These come in a variety of versions. The ones I have are one normally closed and one normally open. So that means one switch is closed and opens when the contactor is initiated, and the other one is the opposite. So that's according to my needs in this project. Below the contactor is a thermal relay. That's like an add-on to a contactor. You can also get them as separate devices. So the current passes from the contactor through the thermal relay, and they come in different ranges depending on what kind of current you're supposed to draw, and you can also adjust within a range. So these are particularly useful when controlling power to motors. Let's say a motor gets jammed or something like this. It will draw an incredible amount of current, and that will be detected by the thermal relay, and it will shut off. So that's like a safety device for your motor. I have 9 separate contactors on this mill. 3 of them are for the main motor, for switching between the 2 speeds and the reverse. And there's also one for the motor brake. There's 1 contactor for the coolant pump, and 2 for power feed, which is run by a DC motor, and 2 contactors for the rapid, which is run by AC motor. So it's 2 separate motors for the rapid and the power feed. And there's an electromagnetical clutch that switches the drivetrain for the table movement between the 2 motors. There's also a controller board for the power feed, and you saw the backing plate right here. Here you see some details of the still unfinished board. There's still a lot more wires to draw, filling up the cable channels there. It'll be full pretty soon, and the same with the connector strip will be full. Transformer has several different outputs for different purposes. 24 volt for the electric circuits or the relay circuits, 48 for switching the relays or the contactors, and also other supply voltages in addition to the 400 four-phase. It's taken me a couple of weeks to finish the main electricals part of the mill. The last thing I need to do on the actual electro cabinet is or not the last thing, but before I can mount it into the cabinet, is connecting the main switch, the main power switch, and the speed selector. There's a separate switch for selecting speed 1 and 2 and forward and reverse. In addition to that, there's some other connectors that I need to connect in. Part of the project like this is always ordering parts, waiting for parts, finding the correct parts, etc. And I've been, putting quite a bit of research into finding the right contactors, talking to suppliers, finding wires. Usually from the suppliers I use, you have to buy like 100 meter at a time, and I haven't, I have no need for that. So I've been sourcing wires from different vendors and shops around. So, things take time. There's always a couple of days delay, to get parts, and suddenly you find out you run out of something, and you have to wait for that to arrive, take you 2 days. There's always something else you can do, but, things take time. And also there's been, I've been studying the diagrams, the electrical diagrams. There's a bunch of them, and when you get down to the details of actually implementing, you just have to be sure you understand. Also, some of these old switches are a little bit worn, so I had to open up some of them to find, what didn't work. I've been ohming through all of them, and things they just tend to expand. Projects like these are always bigger than you think when you start. So anyway, it's as soon as I finished this, it's time to put the board into the cabinet, and it's really heavy, and especially, oh, sorry about that, especially because of the transformer. So it's really a two-man job, but and here you can see all the wiring is ready, all the connectors to the contactors, auxiliary switches. That's my main board that you haven't seen me make yet. It's just called the Schaublin main board, and got my name on there as well. In the next video, I'll be making the circuit boards, the relay boards that control the contactors, and I'll also hook up the switches and everything on the front panel, and putting the main tableau into the electric cabinet. So hope you didn't find this too boring, and thanks for watching. See you soon.